so this Monday we already have the initial distribution for the TCP control. We have AIMD. All right. And of course, we have additive increase. And after the losses event, then we will have the ND, multiplicative decrease. Well, why? Actually, we want to find the optimized performance. So of course, we want to have it. Therefore, we have this, right? We want to optimize the congestion flow rate. That says we want to call it congestion window. Of course, only the AIMD, no. In fact, we have the others. Slow start. Later, we will already know slow start. Well, so we want to control the transmission rate. Therefore, we want to control the congestion window. Right? Similar to the TCP, we have the current window. Right? So we have the window. We try to have the dynamic size. Alright, so we want to have the dynamic size, and so that we have the upper window. So this is a congestion window. Well, so similar to the previous description of the TCP, we have the congestion window. The control window should be the dynamic version. Of course, we expect to have AIMD first. Alright, so we want to limit to the window. How to have the dynamic control? This one. We want to use congestion window CWND. It is dynamically adjusted. And how to adjust? Later we will already have the initial one slow start. But currently, if we want to have the rate calculation, we can roughly use the current value CWND and use the round trip time RTT. Therefore, we can have the rate estimation. Here we have a slow start. This Monday I already know slow start means I want to start when the window stays at the lower rate. So it is called slow start. Therefore, we want to start from the initial value. It's 1. We have the unit is the maximum segment size, MSS. And right now we want to increase exponentially fast. Well, exponentially fast. So how to do? Currently, we try to use best of 2. So use best of 2 and increase using this order. Alright, exponential order. Therefore, how to do that? We will implement using the current way. So this is a way to implement. Double the congestion window every RTT, right? Every RTT. So time unit every RTT we can double. So of course we increase using the exponential manner with the base of 2. Well, so how to do that? We use this one. It's done by incrementing the CWND every act receive, and then we can implement the exponential fast increase. Well, this is the implementation. We have act receive. Then we need to increase the window. So initially it's 1. So here we have a +1 because based on the implementation. We have 2. So we send 2. Send 2, then here, once we receive 1, then we have 1 plus 1. And next one, we have 1 plus 1, so it's 4. Therefore, we have 2, 4, next one, it's 8. Let me emphasize, this is a way to implement. When we receive act, then we increase the window by 1. and so that we can double the window this way. Well, so this is the description for slow start. Initial rate is slow, but ramps up exponential fast. That's why we'll use this one to have the exponential way to increase. Alright, so this is a trend, exponential way to increase. And so that we have this one. Alright, so this one is a slow start. In shorthand, SS, slow start. So we have a slow start, then we will have the AI here. AI here, additive increase. We call this is a congestion avoidance, CA. Congestion avoidance. Previously we have AI. We have a new term here we call congestion avoidance. Therefore, we have a slow start followed by AI or the congestion avoidance. Well, so we expect to have that one. And after AI, possibly we have MD or here. So we have MD and MD like this one. This one half. So half it, this one decrease to 1. So we have two choices, half or decrease to 1. Well, so we have a slow start, congestion avoidance is AI, and then we have a losses. So we have MD to half of the congestion window or maybe to 1. Before we have the further setting, let's have the checking for the question here. When should the exponential increase to switch to linear? Here, linear. In fact, we set a threshold value. It is SS threshold. So it is the slow start threshold value. Well, in fact, we need to set SS. Once we have SS, if we reach SS, then we need to switch to the linear one. And how about if we have a loss event? And then we need to half or need to decrease the congestion window to half of the current congestion window or maybe to 1. Well, so we need to have the threshold. And once we have the threshold, and how to set the new threshold if we have losses, this one. If we have the losses, we have CWND, and SS here, set it to CWND. Alright, so initially we have the SS setting, and after that one, if we have the loss event, then we will have the congestion window and set it to the SS. Now, of course, for the congestion window, because we have two kinds of MD, possibly it should be half, and possibly it should be 1. So, can be 1 or can be half. Well, so let me erase the current annotated description. So, we have this one. We have a slow start. We have AI, or here it's called congestion avoidance. Then it's MD. MD version 1 and MD version 2. Version 2, we need to have a slow start again, and then AI or congestion avoidance. Well, so the current one, we have the description. Well, this is a rough setting because TCP will have a slight modification. Specifically for AI, it doesn't mean we have it because we have the actual value plus 3. Where we have a plus 3, this one. Well, We have the summary for the previous description. We have A, I, and D. And we have a slow start. Let us start from slow start. Here we have a slow start. And slow start, check it. We should have the initial setting. Where we have the initial setting. This one. Initialization, right? Here we have the initialization. All right, and this one, initialization. We should have a congestion window start from 1, and we have a SS fridge setting. And of course, we have a duplicate act description. It's 0 now, no duplicate act. And actually, if we have a duplicate act, what to do? Increase. And if we have a new act, previously we have the implementation. Once we receive new act, then we need to increase CWND by 1. So here it's 1. Am I right? So this is the implementation of the slow start. Once we have a congestion window exceed the threshold, then we need to switch to CA or AI, right? Well, up to now, I think about the slow start description and the transition from slow start to congestion avoidance. It should be okay. Am I right? And let me check the next one by jump to the timeout first. Here, if we have a timeout, then we will set the congestion window to 1 directly. So that says we have 2 versions of MD. If we have a timeout it should be a serious event. Therefore, we think we need to start from 1. So timeout here, and we have a timeout, and also we have a timeout. So slow start, we have a timeout, set it to 1. The other phase fast recovery timeout, and actually for congestion avoidance, we have a timeout. So maybe let me switch to a different color. Timeout. And timeout, and here timeout. Even we have different phases: slow start, fast recovery, and congestion avoidance. We have a timeout. Once we have a timeout, we set congestion window value to 1 and restart. As for the other parameter, I think you can check. SS set it to half of the congestion window. You can see this. Right? So I like to have a timeout, and next one, let's check congestion avoidance. For congestion avoidance, actually it's a spatial scenario. For the spatial scenario, actually we expect to have the linear trend. For the linear trend, how to implement? If you think, okay, it's a linear way, that's fine. Linear. But how to implement so that we have the linear trend? This one. We have the 1 unit, MSS. And this one we rewrite here. Something like we have 1, and this one it's CWND and over MSS. Something like, well, we have a CWND. And CWND, look at this. We have the unit, actually it's byte or bit. And CWND over MSS, that says we normalize to count in MSS, right? We have, for example, K bytes for CWND, and maybe currently MSS is, for example, 5 bytes. So use the ratio, then we can count how many MSS in the current window. For example, finally we have the value, it's 8. So we have the congestion window in MSS, it's 8, for example. And how to increase? We increase a bit, finally increase to a single MSS. And this way, we can implement the linear trend. So the current setting, actually, we can have the linear trend. And this linear trend for the congestion avoidance. And in fact, if you have some idea using linear, of course, you can use that way. But if we use the current setting, CWND equal to CWND multiply MSS over CWND, nothing wrong because this one is the linear trend implementation. Well, so this is the linear trend, so of course it's AI. Well, and if we have a duplicate act, then we increase. Alright, however, we have a fast recovery. What it means fast recovery? Fast recovery, in fact, we will detect duplicate act reach the set value. If we have the preset value to 3. Therefore here, we have a duplicate act preset value to 3. Then we will switch from the current AI to the fast recovery. Right? That says don't wait to time out, run out. It should be some loss event so you can have the fast recovery. But fast recovery, look at this. Then we have SS equal to the current congestion window over 2. However, congestion window size is the current value plus 3. So I emphasize plus 3 here. Well, the current version is different from the previous version because we have plus 3 for the fast recovery. Alright, so I emphasize we have plus 3. And then we retransmit the missing segment because of the fast retransmission. But during the fast recovery, how to continue? Actually, if we have the duplicate act, still allowed to have one extra MSS, something like, oh, the current one similar to the slow start to increase the rate exponential fast. Because fast retransmission, we want to solve or to resolve the current problem fast. Well, so within the fast recovery about CWND, it's not the linear trend. Instead, it's the exponential trend and descent, right? Alright, so once we reach new act, because of new act, obviously it's okay, then we will reset. Reset CWND to the previous setting. Actually, it's half of the previous congestion window, so set it to SF first. And reset the duplicate act count to 0. And likewise for this one, if we have a fast recovery, then we go to the phase of a fast recovery. And likewise, we have plus 3. Well, so I highlight the two classes plus 3. And also allow the congestion window increase exponential fast because plus MSS. So if we have a duplicate act similar to the new act, we increase the window and so that we can fasten the transmission within the fast recovery. Well, so this is the current discussion. about the summary for TCP congestion control. We have 3 phases: slow start, congestion avoidance, fast recovery, and we have other details about Class 3 because the version different from the previous description. And also the current congestion window way to increase we use exponential fast within the fast recovery. Well, this is the TCP congestion. Well, attendance checking before we have the activity. I already have the attendance checking first. So check it. If not okay, let me know. Likewise, that you have 2 minutes to check these. Not okay? Alright. So let me show you using this way. Alright, go and check it. Let me reset. Some of you join online, so that's why I already have 2 minutes. And before I continue, let me check with the students in the classroom. Now, okay, raise your hands. So, okay for students in the classroom. And we still have 30 seconds to go to the next page. So, wait for you if you stay online. So let me get back to the slides. Well, I think we have the summary for TCP congestion control. Before I want to let you have the activity, let me measure your comprehension status. If okay, let me know understood well. If you still have some other questions, let me know where I need to re-explain. Of course, you need to show your ID, name, and group ID. And this one, I'm not sure, but let me check again. If not okay, then let me know not okay. So try this one again. Or should I go to the different page? So for this one, is it okay? It's okay, right? Alright, so let me get back to the slides. If any questions are still online, you can tell your friends so that I can understand something wrong. So, about the TCP congestion control, I already have the thin pair shell. And for the thin pair shell, actually, I already have it last time, right? So currently, you have the hyperlink on our line group. Or maybe if later, yes, you want to scan the QR code, I can show you the partly QR code. So we have part of the current problem talking about TCP congestion control. We have a slow start, congestion avoidance, fast recovery. The current fast recovery version should care about Class 3. for the congestion window setting. And currently, if we have a curve like this, we should ask you to identify interval when we have a slow start, when we have a congestion avoidance, when we have the other event, and how to have the value setting. And currently, we have a subproblem A, B, C, D to the others. I'm using the increasing order. Group 1. If you want to have the presentation, focus on subproblem A, B. So the first two and group 2, 3 to 4. Group 4, maybe we don't have a group 3. Group 4, 5 to 6. And group 6, 6 and 7 to 8. Yeah, maybe for the remaining two, we don't have the presenter, but that's okay. If you think you want to have the idea sharing, later you can show me that. For the discussion, I allow you to have 5 minutes to check. Okay, go 5 minutes to check the problem. And if indeed you want to scan the palette here, this is a palette for you to check the content there. If you don't have it, yes, you can use line code to find a hyperlink. So that you have the way to think. So this one. Feel free to discuss with your neighbors. And if you want to earn the points of bonus, you can try to share your idea for the two possible subproblems. If yes, then you can upload your answer for the presenter. And likewise, we have at most 2 minutes for the presentation. For your subproblems only. Let me make sure. Group 1. Try to have a presentation. Anyone? It's easy, right? Identify slow start. So try. If yes, then upload your answers. Which one to serve the presenter, you can share with the other members. And group 2? Any presenter? Yes or no? No? Okay, no this time. Fine. And group 3? Oh, sorry, group 4. Sure, you can upload. So we have a presenter from group 4 and group 6. Any presenter? If yes, later you can upload your answer because we have to present first and later you have a chance to present. Alright, so group 1 upload the answer too. Group 1 and show you are the presenter. Who will be the presenter? And let us speak louder. So for CR Online, actually I have a different scene switching. Therefore, maybe later you can check YouTube, then you will know what it means, scene switching. At least for the current discussion, good one. Sure, do it fast. And good for if you're ready, then you can let me know. And for the other groups, if they still have the chance, sure, you can upload your answer and to have for the presentation. Current time is 11. Possibly we can have the presentation by 2 or 3 groups or even 4 groups today. So do your best to have the possible idea sharing. All right, so we have an answer from group 4. Group 4, let me make sure again your name in English. Brandon. Okay, Brandon, actually I have my own problem here, presenter. If you want to show the problem, you can go to the window there. And you can show your solution here, double click. All right, so come here to have the presentation.
Oh, okay.
2 minutes. And then question. Okay. Get back.
Okay. Okay, so our part is about the question E and F. Okay, and so it asks about the initial value of SSTH and after the 20-second transmission run. So let's get back to this figure. Okay, so as you can see, at the run 6, the curve just turned to the linear form from the original exponential growing part. So the injection point happens at the run 6. So we expect that the initial value of the code should be about 23, I guess, about just approximately, because we cannot see the precise value on the figure. So it's approximately 32. And for the 20-second run, as you can see, it grows to the about 30, and then it drop to 1. So the half may be also about 30 divided by 2, so it's about 15. But just as the first question, I cannot see the very precise value, so we just approximately get the value. It's about 15. Okay, so that's our answer.
So you can show your answer directly.
Oh, sorry.
Switch and show your answer directly. For you should focus on E and F, right?
Yeah.
32 and 15.
15, but
approximately.
Yeah, approximately.
Of course, you should start from the first one to the final one before 4 p.m. today.
Okay.
Likewise.
Yeah.
But this is a reference value. Okay, this is a presentation by Group 4. Thank you. Go on. So if ready, then you just upload. Then I can allow you to have 2 minutes to have the presentation. And of course, right now it's the thinking time. So go on. Yes, right. And good too. Same. Up now, no presenters. Good too. No. And good 6. Yes or no presenters from you? No. Currently no. Okay, fine. So we have the answer, reference answer from Group 1. Good. But let me switch to scene 4. Come here. Your name in English? Anita. Okay. Anita, you can speak louder. Of course, you can check the problem here, and also you can show us the answer finally. Okay, go. 2 minutes.
So for the first question, we think that this low start of this TCP should be round 1 to 6 because it rises the most rapidly. For the second question, we think the congestion avoidance should be round 6 to 16 and round 16 to 22 because it's growing a little bit slower in a linear way.
So can you use mouse to highlight where we have a slow start? Yes. Yes. And next one. Next one, slow start. We still have a next one, slow start. Yeah, next one. And also, congestion avoidance. Where we have a congestion avoidance?
Round 6 to 16 and 16 to 22.
Okay, fine. So finally show your answer quickly.
Okay.
So A, you have a round 1 to 6.
Yes, we didn't
Actually, you have the second slow start. And congestion avoidance, yes, you have 2 periods. Okay, that's it, thank you. But Carol, now, all of you, you can check again. All right, thank you. Well, so today we have the 2 presenters. And then we make sure again for good 2, still no, right? And good 6, still no, right? All right, so if no, let me get back to the slides. So you still continue the answering on Padlet before 4 p.m. as usual. The problem actually we have many sub-problems, so take time to finish it and then I'll go to the Padlet. Even we have too many sub-problems here that we have 5 points for the current problem because we have the unified points, 5 for each problem. So just 1 problem, so still 5 problems here. And can we have the improved version? Yes. We have the following improved version called TCP cubic. Cubic actually from cube, C-U-B-E. And the version here because of cube. So we have cubic. Actually cubic coming from a paper from researchers of Korea. South Korea, 1 team of researchers proposed a new version, cubic. Well, so it says, any other better way to probe the usable bandwidth? Of course, yes. So actually, we have the current version. The current version code, AIND. And if we assume the same level, so we just care about the same level, AIND, within possibly half of the maximum window size within the current interval. And we have AI to probe properly. Is there any other way to probe it? Here, this one. We have the description, this description. Check it, this. In fact, we can ramp to the maximum value faster initially. Initially faster. And slowly once we approach it. So, the way to implement the current description says, ramp up faster. Slow down once we approach. Am I right? And the current train using the function of a cube. That says we have a cubic version. Am I right? And for each one, yes, same. And how to implement this one? Actually, we will have a point. For example, K here. Assume we can find the position K here. We can try to find for the current window. Find the distance near K, so it should be small. Far from K, it should be larger. Larger than we increase faster. So you see K. And so that we can increase is the manner cube. For example, current time T multiply K raised power to 3. So it's cube. For each window, we always apply the current way, and so that we can have the cubic version. Where we have the implementation of a cubic linear system. Alright, linear system. And because of this, and because of better performance, it becomes popular for web servers. Well, so this is a version, improved version of the TCP congestion control. We call cubic, and we still have another version, but while that we have the discussion, possibly next week. And this time, maybe I think maybe I will use some classes next week to finish chapter 3. All right, so this is all for today. And before you go, any questions? If no, see you next week. And next week we will have the version, advanced version code, BBR version for TCP congestion control. And after that one, we will have the fairness issue for TCP. All right, that's it. See you.